Hello, in this video we're going to review adding integers using integer tiles. We're going to find each sum and we're going to show our work using drawings. The drawings we're going to do are integer tiles. So problem number 1 is 4 plus negative 6. So when you're using integer tiles, you're going to skip 2 or 3 lines. And since 4 is positive, I'm going to draw 4 positive tiles. Positive tiles are just circles with plus signs inside them. And you're adding negative 6. Negative 6 means you have circles with negative signs in them, and negative 6 means you have 6 of them. And when you are solving these problems using integer tiles, the big thing you have to understand is that a plus and a negative combined together make 0. They're called a zero pair, which basically means they cancel each other out. Positive and a negative cancel out to be 0 because they're equal. A positive, negative, zero pair cancels out, zero pair cancels out, and zero pair cancels out. Now, all 4 of the positive tiles canceled out, leaving us with 2 negative tiles, so the answer is -2. So when you are doing integer tiles and the signs are different from each other, you have 0 pairs and you cancel them out. Our next example is -2 plus 5. So again, for -2, I will draw 2 negative tiles, plus +5, I will draw 5 positive tiles. You find your 0 pairs. And your negative and positive cancel each other out because they're 0. Your negative and positive cancel each other out because they're 0. And of the 5 positive tiles, 2 of them canceled out, leaving you with 3 positive tiles. Problem number 3, I'm going to do the same way, but the end will be slightly different because -1 means that I have a -1 tile, but it's plus -4, which means there are 4 more negative tiles. There are no 0 pairs here. Nothing cancels out. There's just 5 negative tiles. And since there are 5 negative tiles, your answer is -5. You only cancel things out when you have 0 pairs, when you have opposites of each other. I'm going to do a few more examples. When you have 3 numbers, then you do it pretty much the same way. You start with +6. +6 means you have 6 positive tiles. 1, 2, 3, 4, 5, 6. Added to a -8. Now -8 means we have 8 negative tiles. And then there's +5. So for the +5, I'm going to add 5 more positive tiles, 1, 2, 3, 4, 5, to the end of the tiles I already had. I cancel out all of my 0 pairs, and when we're done, there are 3 positive tiles left over, meaning your answer is a +3. Now that's how you do this using integer tiles. You could also do these problems by using a number line. If you were using a number line, you always start at 0. And if we're doing 4 plus -6, 4 means you go 4 to the right, 1, 2, 3, 4. Adding a -6 means go 6 to the left, 1, 2, 3, 4, 5, 6, because going negative or minusing always goes left. And that leaves you at -2, same answer that we had. If you're doing problem number 2, -2 plus 5, you'd start at 0. -2 means go left twice, 1, 2. And +5 means go to the right because it's positive 5 times, 1, 2, 3, 4, 5. That brings you to +3, which is the answer we had for number 2. Problem number 3, again, starting at 0, -1 means go 1 to the left. And when you add -4, you go 4 more, 1, 2, 3, 4 more to the left, putting you at -5, which is the answer that we had. So you can always use integer tiles when you are adding your integers together. Some people might like using a number line better, but I also, because there will be times when you have much larger numbers in the 20s or 30s or hundreds, where you don't want to draw out that many tiles or draw a number line that large. So there are rules that go along with doing these problems. The rules are when the signs are the same, add the numbers, keep the sign. So for example, in problem number 3, the signs were the same, they are both negative. You add the numbers 1 and 4 and get 5, and you keep the sign. They are both negative, it's negative. In problem 1 and 2, the signs were not the same, the signs were different. When the signs are different, subtract the numbers and take the sign of the one with the larger absolute value. Basically, take the sign of the larger one without looking at the signs. So for example, in problem number 1, the signs were different. You would subtract. 6 minus 4 is 2. And since 6 is a larger number, the answer is negative 2. Problem number 2, again, the signs were different. When the signs are different, you subtract. You just do 5 minus 2 is 3. And since 5 has a larger absolute value and 5 is positive, the 3 is positive. Now, when you want to show your work algebraically, you can do the rules or use the rules when doing problems instead of having to draw tiles or use a number line. So if I have 7 plus negative 9, remember, that's addition, you do the one that comes first. 7 and negative 9, the signs are different. When the signs are different, you subtract the numbers and take the sign of the one with the larger absolute value. So 9 minus 7 is 2, and since the 9 is bigger, since the 9 is negative, it's negative 2. And then I would copy the things I did not use. I did not use the plus, I did not use the negative 4. I copy them. And now I would do negative 2 plus negative 4. Now, for negative 2 plus negative 4, the signs are the same. And when the signs are the same, you add them and keep the sign. So 2 plus 4 is 6, keep the sign, and that would be your final answer. So when you are adding integers, there are 3 methods you can use. When you have smaller numbers, the 2 methods of using integer tiles, where you draw a tile for each number. So 4 would get 4 positive tiles, negative 6 would get 6 negative tiles, and you cancel out the 0 pairs. That works for smaller numbers because you can draw the tiles. If you like the number line better for negative 2 plus 5, when it's positive numbers, you go to the right, and negative numbers, you go to the left. And you can use those on smaller numbers. When you have much larger numbers in the 20s or 50s or hundreds or bigger, then you may want to stick to knowing the addition rules, which means understanding the addition rules. When the signs are the same, you add them and keep the sign because if you're thinking of tiles, they're all the same. You add them and that's the sign. If you're thinking on the number line, if the signs are the same, they're moving in the same direction. You keep the sign. When the signs are different, like they were in 1 and 2, then you're going to be canceling out. That's like subtracting. Of the 6 negative tiles, 4 of them canceled out. Of the 5 positive tiles, 2 of them canceled out. It's the same as subtraction. And on the number line, when you move in different directions, if I have 4 plus negative 6, it's 4 to the right, and I'm at 4. But once I add in negative 6 and go the other direction, the first 4 get me back to 0, which is why you have 2 left over to go left. So when you go in different directions, you're going to subtract. And that is the reason for the addition rules, or where the addition rules come from.